In this class, we're going to consider the Cartesian coordinate system, which you might already be familiar with just as the xy axis or the xy plane. It's just how we specify points in 2D space using an ordered pair of coordinates. So we call it Cartesian because it was named after René Descartes, who was a mathematician and philosopher who kind of formalized this system like hundreds of years ago. And it's a fairly simple idea, really, just to order points by a horizontal and a vertical move. But it's actually very profound. It's really useful to use this system in various ways in math techniques, in particular to represent the graphs of functions, which you'll see, or maybe you've seen already, but you'll certainly see in the future in pre-calculus and calculus class. So just to lay down some fundamental ideas in this class to make sure that we're all happy with the 2D representation of points. So we call the horizontal axis the x, and we call the vertical axis the y. You can have an xyz plane, and where we add in a third dimension. We'll maybe chat about that later on. But the problem with that is that we're trying to draw on a 2D surface. So if you're trying to draw 3D on a 2D surface, you've got to be a little bit more imaginative. You've got to imagine kind of that third dimension. We'll mention that later. But here we're just talking about 2D space. So this is just a 2D representation of points. And the points have to be ordered. So the order is to put the x first and then the y. That's just a convention. If you move up to 3D space, then it's x, y, and then z. So just go in an alphabetical order, basically. So if we want to specify a point in space, we just measure how far along we're moving from 0, 0. So 0, 0, this point here is a special point. That's called the origin. And that's really where we measure all the other points from. So if we wanted a point that was like 3 along and then 2 up, so 1, 2, 3 along, 1, 2 up, that lands up here. And that is just the point 3, 2, because we put the x coordinate first and then the y coordinate. So that's the point 3, 2 specified by an ordered pair of xy coordinates. The scale, by the way, that I've put on here, that's fine. I mean, most xy planes will have a scale, but the scale doesn't have to be like 1, 2, 3. It could be 10, 20, 30. It just depends what kind of numbers you're working with. You could even have 1, 2, 3, 4 small numbers along the way and then big numbers up the way like 10, 20, 30. It really is very dependent upon the question. And you've got to adjust your scale to fit in with the question that you're working and the type of numbers that you're working with. Numbers can be both positive and negative. So if we wanted the point at -2, say -4, that would be 2 back the way and 4 down the way. So that's going to be the point down here. So that's a point with x coordinate -2 and y coordinate -4. So -2, -4. And that's basically how we just carry on. We just keep plotting points based on their numbers. If you had a point which was on the x-axis, let's say we had a point like right here, then that's 5 along the way, so 1, 2, 3, 4, 5, but it's 0 up and down the way. So that point there is 5, 0. So if you get into functions, pre-calculus, calculus in the future, you're going to be spending a lot of time looking at points that are on the x-axis and the y, but more so the x, for a variety of reasons, which we're not going to talk about here. So knowing that points on the x-axis have got a 0 y coordinate is really important. Try and commit that one to memory. That would be the same if you were on the y-axis, but the other way around. So if you were a point up, say here, 3 up the y-axis, then you've got an x coordinate, a left-right horizontal move of 0. So your x coordinate would be 0 and your y coordinate would be 3. So notice that that's just flipped around the other way. The x coordinate is a 0 instead of the y coordinate being the 0. So if you're on the y-axis, the vertical axis, then your x coordinate is 0. And that's basically how this works. So try and remember the term origin as well. That's quite common terminology when we're talking about xy points. So there's different names given to this. So sometimes it's called the xy axis, sometimes it's called the Cartesian axis, sometimes it's called the Cartesian plane because it's kind of like Like if you imagine it being a sheet of paper, then it's like a plane, so the Cartesian plane. Sometimes it's referred to as R2, and R2 is a reference to, so the R means real numbers. It's a reference to the fact that these are all what are called real numbers along the way, and these are all real numbers. So it's almost like you've got real times real sort of thing to give you R2. So that's just another way. I just wanted to point that out because these are the different ways that it gets referred to. But most commonly, probably, is the Cartesian coordinate system, or just the XY axis is probably what we'll call it most days. Like I said earlier, you can move up to 3D as well, and it's not really a big leap. Just be careful when you move to 3D. I mean, you can't really plot points in 3D because we're moving a certain amount along the way, that's the X. In the 3D space, the Y goes back the way, but that's the problem because we can't draw into the board. That's my issue. We can only draw left and right and up and down, so we're kind of restricted to those 2 dimensions. So we can get the X and we can get the Z coordinate, can't really get the Y coordinate. So even if I started plotting points, they're all going to appear to be at the front of the board because I can't draw into the board. So plotting points in 3D is actually quite difficult. It takes a bit of imagination. So you're probably going to spend more time working with 2D space than 3D. This is still kind of the Cartesian system. We're still measuring points by a triple coordinate. So if you wanted a point somewhere in there, it would need to have an X, Y, and Z coordinate. So it might be something like 1, 2, minus 7. So it'll be 1 along, 2 back the way, and then minus 7 down the way. So that might be in here somewhere, but it's difficult to really think that that's anywhere other than just a long and straight down. We're not capturing that middle coordinate in 3D space. Sometimes 3D space is referred to as R3, just in the same way that that was referred to as R2. So that's just really an overview of the Cartesian coordinate system. There's nothing much to get confused on really there, so don't overthink it. Just remember that all the points are measured from the origin. This is the origin 0, 0. Points on the X and Y axis have got to have a 0 coordinate, either the X or the Y, depending on which axis you're on. Otherwise, you're just counting left and right and up and down to get your ordered pairs of coordinates. So it's basically the Cartesian coordinate system.